What is a black hole? We all have a general idea of what a black hole is, but there are things that may surprise you about it. In a black hole, gravity is so strong that nothing can escape, not even light. Anything that passes close to it will be affected by its gravitational pull. To go along with that, the events in a black hole become very strange. As the time slows down, objects become distorted, and the laws of physics no longer apply. Black holes are formed when a massive star, much bigger than the sun, stops shining and collapses in on itself. The gravity that is left from the star would be so large that it would keep collapsing and become more and more dense. The star would keep collapsing until there was nothing left except only a gravitational field left by the star. If one of these stars is big enough, at least 10 times larger than the sun, their lives are ended a bit differently. They begin to collapse like any other star, but the core squeezes itself so much that a huge explosion occurs called a supernova. When this happens, sometimes the core is so heavy, making it a neutron star, which is much smaller than a normal star, but it is very, very dense. A piece of it the size of a grain of sand would weigh 1,000,000 tons. If this small neutron star is twice as heavy as the sun, it will continue collapsing and just become a gravitational field, like any other star. But since it is a neutron star, this gravitational field will have super strong gravity and become a black hole. So, what is it actually like if you were to go in and around a black hole? As an object gets near a black hole, the gravity of the black hole would accelerate it at the speed of light towards the black hole. Since you're traveling at the speed of light, the light behind you would actually pass in front of you, causing you to see all around you. If you were traveling towards the sun at the speed of light, it would actually appear that you're going backwards at first. Once you get closer to a black hole, it would appear that time slowed down, light becomes distorted, and a process called spaghettification occurs. Spaghettification is the process in which an object is stretched out towards the black hole because of the extreme gravity accelerating at the speed of light. Once it reaches the sphere where the hole begins, called the event horizon, there is no going back. By the time it reaches the event horizon, the object will, with no doubt, be traveling at least the speed of light. Once over the event horizon, the object would quickly become part of the singularity at the end of the black hole. The singularity is an extremely small point in the universe that has no size. The singularity also has an infinite density because the mass of it isn't infinite, but the density is because it takes up no space and has no size. So how do we even know that black holes are real? Well, the truth is, we don't fully even know. But we have some proof that they probably are. They're really hard to find because they're black, because no light escapes from them. They're also very small, in fact, only about 18 miles across. If they were made from massive stars, the closest ones would be numerous light years away, making them really hard to see. Since telescopes can't find them, the best way to search for a black hole is to look for evidence of its effect on other objects in space around it. These effects should be quite large since the gravity is really strong in a black hole. The effects of a black hole could occur on binary stars. Binary stars are two stars that are very close together that orbit around each other. If one of these massive stars dies, it would become a black hole since it is so large. Now, the single star would continue to move as if it would still be in a binary system. This is evidence to scientists of a black hole. Another way scientists can find evidence of a black hole is X-ray proof. One way we could use X-ray proof is by observing a gas nebula. A gas nebula is a cloud of gas and dust in space. If the black hole accelerates the speed of this dust and gas towards it, the nebula would be heated to very high temperatures. This would cause it to give out light, but other types of radiation like radio waves would also be shown by X-rays. Using certain telescopes, they could spot the radio waves. Along with X-ray proof in binary stars, scientists can also observe X-ray binaries. If one massive binary star collapses and becomes a black hole, this black hole will begin to suck in the gas from the binary star that is still in the binary system. As the black hole is sucking in this gas, it will begin to spiral. Using certain telescopes, scientists can detect the heat in X-rays that spiraling gas would create. In conclusion, scientists are not 100% sure if black holes exist. But there have been case studies that could have proved the theory, like the Cygnus X-2 and the M87 galaxy. Who knows? Maybe you'll be the one that 100% proves the theory of black holes.